there is another factor, and that factor is Coriolis force. That factor is Coriolis force. If you look at Coriolis force, it is called as a fictitious force. It is called as a fictitious force. Means it is not real, or there is no such like reason behind it. Like when you see at the centripetal force, you know that centripetal is the force which is acting towards the center. So then just a opposite force exists, centrifugal force. In the same manner, we know that the earth is rotating. The earth is rotating in a particular direction. The earth is rotating in a particular direction. So due to the direction of motion of earth, we see that there is a force which comes into picture. Okay. So what we see that it is not a real force, not an original force. It comes into existence. It comes into existence because of rotation of earth. Because of rotation of earth. Okay. So Coriolis force comes into existence. Coriolis force comes into existence because of rotation of the earth. Okay. Because of rotation of the earth. So that is why this comes into the picture. This comes into picture. Okay. So otherwise there is no such existence of Coriolis force. If the earth stops moving, then there will be no such Coriolis force. Like suppose we have the earth over here. You know that this is equator 0 degree, and here we have 30 degree. Here we have the 30 degree. Now in general case, you know that the air is flowing like this. This is the normal circulation at present. This is the normal circulation in present times. Okay. But suppose that when we see this, that suppose earth was, if earth was not rotating, so then what we will see that the wind would have come simply in this manner. The wind would have simply come here. Okay. So it is the rotation of the earth which gives rise to a force, a fictitious force, which is what we call as Coriolis force. So we know that this is the direction of motion, west to east. That is the direction of the motion of earth. So a force is acting due to this direction of motion. A force acting in opposite direction due to this direction of motion. And hence what we see that we have the Coriolis force. Now, what is the Coriolis force doing? What is the Coriolis force doing in case of north hemisphere and in case of south hemisphere? We see that this Coriolis force it is deflecting winds in first clockwise direction, in north hemisphere, and anti-clockwise in south hemisphere. anti-clockwise in south hemisphere. Generally, you remember this one part. Generally, you are remembering this one part that we have left bending or right bending, and there you will get confused. When you see that there is left bending or right bending, you get confused over there. So there is one simple thing. It goes clockwise and anti-clockwise. Let me explain what does that mean. Okay. Suppose that you have a watch. Okay. Now you see that there is 12, 3, 6, 9. You will find that this comes to 3, then this comes to 6, then it comes here, then it comes here. So if the direction is motion is like this, if the direction of motion is following, the clockwise direction, and if suppose that it starts going like this, it starts going in opposite direction. Okay, it starts going in opposite direction. So then it will be the anti-clockwise direction. Then it will be anti-clockwise direction. So let's look at this. Now tell me here, is it a clockwise direction or an anti-clockwise direction? When you are looking at this, in the case of northern hemisphere, what we see, is it clockwise or not anti-clockwise? It is clockwise direction. Okay. And when we see here that when the air is coming and it is moving in this direction, it was supposed to go like this, but it has moved in this direction. So it is clockwise or anti-clockwise? It was supposed to move in this direction, but it has gone here in the southern hemisphere. So it is clockwise or anti-clockwise? In the southern hemisphere, anti-clockwise. Okay. So this is one part. You always have to remember just this one thing. If you remember clockwise and anti-clockwise, you will never get confused in northward or left or right. Okay. You will not get confused in this left or right. Okay. Now see here. Okay. That let us say if we are having that one wind is going up, okay, and another wind is going down. Okay. So tell me here, which one will be correct? Which one will show the correct deflection? Will it be option A or will it be option B? Which one is going to be correct one? A option or B option? Here we are talking about 30 degrees south. Okay. We are talking about 30 degrees south and 60 degrees south. You know that this is an area of high pressure. This is an area of low pressure. This is an area of high pressure and low pressure. Which one is going to be correct? A option or B option? And here, A option. How come A option? Tell me, what will be the anti-clockwise panorama in this case? In this case, what will be anti-clockwise? You know that here it has to be anti-clockwise. So when the clock is at 6, will it go towards this? If the clock is at 6, what will be anti-clockwise? B or A? The actual direction of motion has to be like this, that it was going in this direction. So we know that it is anti-clockwise in south. So when we say about anti-clockwise, so it is going in this direction. Okay. So then it is going in this direction. Okay. So here what we see that in this case option B will be correct. Now tell me about this one. That here option C or option D, which one will be correct? Option C or option D, which one will be correct? Also 30 to 60 degree anywhere in the entire southern hemisphere. This is the total southern hemisphere and this is the total northern hemisphere. Okay. This is the northern hemisphere, this is the southern hemisphere. Are you having confusion in northern and southern hemisphere? This is valid for the entire southern hemisphere, that it will be anti-clockwise. And in case of northern hemisphere, it is going to be clockwise. So here C option will be correct and here B option will be correct. So on the basis of this, if you see the direction of wind, we have drawn it earlier also. Okay. We have seen it earlier also that it comes like this. In the case, it is going like this. Then what we will see that in this case, so this is going to be the direction of wind in the case of, this is going to be the direction of wind. Okay. So when we see about the Coriolis force, this is impacting, this impacts direction of wind. First we have seen that it is impacting the direction of wind. Okay. It is impacting the direction of wind. Now see one more thing, that why actually this clockwise or why this anti-clockwise? That why we are having this clockwise or anti-clockwise movement of this wind. Okay. Now see here, we are having the earth. Okay. And if you look at this, you will also understand that Coriolis force is something which we believe that it is existing. We believe that it is existing, but it is actually due to the rotation of earth. Otherwise, there is no existence of Coriolis force. Okay. Just see this one part. Okay. Right now, look at this. A, this is location B. Here, it is location C. And here, it is location D. So, a wind started to move from A towards B. A wind started to move from A towards B. But during that time, you know that the earth is rotating. The earth is rotating. And you may have seen that when you are throwing the water, just to give you an idea, suppose you are moving in a train and when you are throwing the water in front also, you will find that it is taking a turn. If you are throwing it in front also, you will find that it goes backward actually. If you are throwing it, like suppose you are throwing, here you are in a train, okay, the train is going like this. Just suppose the train is going like this, you are throwing water in this direction, you are throwing water in this direction, will it reach this point? Will it actually reach this point? If you are throwing it also in this direction, will it reach this point? So you will find that there is a curve which is going to be created. There is a curve which is going to be created. It is not going to exactly go at this point. It is going to curve. So think about this. This air which is moving, the earth is rotating. So by the time this air reaches here, you will find that this B point, the A goes here, B reaches here, and the wind is actually reaching at this point, which becomes D later, which is becoming D in later course of time. Okay. So the point A has moved ahead. It was supposed to come to B, but the point B has also moved ahead. The air is reaching at this point D. The B becomes the new D. Okay. In same manner, think about this. Air was going, here also take 4 points, here also X, Y, Z, K. It was going from X to Y. It was going from X to Y, but the earth is moving in this direction. So by the time X becomes here, Y becomes here, this Y actually becomes what? This will become K. This is going to become K. So actual movement will look like this, that you try to throw it towards Y, but actually it has reached K. Why? Because the earth has rotated. The earth is always rotating. So in fact, what you will see, that's why I have written one thing in the beginning. Coriolis force is a fictitious force. It is not a real force. It is not a real force. It exists because the earth is rotating. If earth was not rotating, we would not have even discussed about this Coriolis force. And now you can see the region why the air seems to have moved, or why the air seems to have taken this direction. It is not the air which is actually taking the direction. The earth itself is moving. The earth is moving, and that's why it appears to us, it seems to us that the air is following this direction. The air was simply coming to this part. The air was simply coming to this part. But because the earth has moved there, that's why it appears to us. That's why it appears to us that it has gone in this direction. Okay. So this is one part why we see that. Okay. Why we see that there is movement of earth like this. Okay. So that is the region. That is the region why it seems that this is the point where the air is reaching. Okay. So I hope this one part is clear. The Coriolis force is not actually a force. Coriolis force is a fictitious force which exists just because of rotation. Okay. If the earth has rotated, if it was going in this direction, earth has rotated, so it seems that this has shifted. But in actual, the air is not shifting. In actual, what we see that the air is not shifting. It is the shifting. Okay. It is the shifting of the wind. Sorry, it is the shifting of the earth which we see over here. Okay. So that is the region. Okay. The rotation of earth is west to east, then why wind deflect in anti-clockwise direction? Okay, I'm saying you, Tell me about this part. The earth is moving in this direction. The earth is moving in this direction. If you are going through a train and if you are throwing the water, will it go in front or will it go in the back? Because your position has moved, so it will seem that the air is coming in the back side. Acha, this is anti-clockwise. Tell me how this is anti-clockwise. The air was going like this, it has moved here, so is it anti-clockwise? The air was going like this, it has moved in this direction, so is it anti-clockwise? In southern hemisphere, it is always anti-clockwise. In southern hemisphere, it is always going to be anti-clockwise. Okay. Now, there is one more part here. There is one more part here which you have to understand, and that is the Coriolis force. Coriolis force is directly proportional to latitude. Coriolis force is directly proportional to latitude. Okay. There is a balance. There is a balance between Coriolis and rotation force. At the equator, the rotation speed is highest. Okay. At the equator, the rotational speed is highest. But at the pole, the rotational speed is minimum. So what you will find that there is always a balance between the two. There is always a balance between the two. That at this point, what we see that the Coriolis force is directly proportional to latitude. Okay. It is directly proportional to latitude. So at the equator, it is almost zero. At equator, where the rotation speed is highest, okay, at 0 degree, Coriolis force is almost zero, and at 90 degree, at 90 degree, Coriolis force is highest. At 90 degree, the Coriolis force is highest. So maximum deflection will be seen. Maximum deflection is going to be seen in the case of polar areas. And in the case of equator, there will not be any such deflection. So what we see that at equator, it will be almost zero. And at the poles, it will have the maximum deflection. Why northern hemisphere make clockwise direction? Why not make anti-clockwise? Tell me one thing. This is the northern hemisphere. Forget about that why it is making clockwise, or forget about this part that it is clockwise or anti-clockwise. Tell me this one simple thing. If the wind is coming towards this direction, if the wind is coming from point like O to point P, okay. If the wind is coming from O to P, and we see that the earth is rotating, so will the air reach here at point P? Will the air reach here at point P? Where will the air reach? Will it reach here at N, or will it reach here at L? Where will this air reach? Air is coming from O to P. Why the air is coming from O to P? Here we know that there is high pressure. Here we know that there is low pressure. So where will the air go? To the point L or point N? Where will this go? L. Okay. So it has gone to point L. Now tell me what type of direction it is. It is clockwise. Okay. I will come to that part. I will explain this 60° also, 90° also. Okay. I will tell you the formula also if you want to know that how the angular velocity and everything is related. If you want to go in detail of that, I will tell you that also. That how the this Coriolis force, how their formula is decided, how it is related to angular velocity. So we will go into that also. Okay. So we will see that in detail, that at 90°, what will be the impact of the Coriolis force, how it will create the polar vortex also. We will see that also, but wait for some time. Okay. We will see this part also, that how it varies or how it creates the polar vortex in the case of the poles, why it is maximum. Okay. So wait for it, we will discuss that part. Okay. Now how it reaches to the L. Tell me about this one part, when it is earth is moving, when the earth is rotating, the portion which was O here will remain at the same position, or it will come to other portions. Will it come to other portions or not? This O which was here, it has shifted to the new position O, and the N which was there, it has shifted here. The L was here and the P is here now. The wind started from here, so it is coming to this point only. But by the time it reaches here, this P has shifted ahead, it has become L. So when we track the motion of air, it actually seems like this, because this position has shifted ahead. It is same like you are just going on a bike or a train and you are throwing the water outside. It will not go in a straight direction. It will go in the direction behind you. So that is the reason why it shifts in this direction.